Right, so we started our discussion on the long question. The first one is preparation of silver nitrate is the direct reaction between silver turning and corn nitrate acid. First one, what could you see? And give with equation. Metal dissolve. And don't forget, nitrogen dioxide will be given out, which is a brown gas. And here is, it is not a good idea to write metal dissolve alone because it is too general. For the chemical equation, if you have no idea, please start with ionic half equation. And this is the half equation for corn nitrate acid. Please remember that the nitrate acid should appear as mobile ion. And for the silver one, so we combine them together and we get our answer. Next one is how crystal of silver nitrate can be obtained from the reaction mixture. Now, you should pay attention is from reaction mixture, which is an aqueous solution, and what you get is a silver nitrate crystal, which is a solid. The point is, it is exactly the same as preparation of soluble salt, right? And we start a new page for that. If you have no idea, try to remember the case. How can you prepare a zinc nitrate crystal from zinc react with nitric acid? So the first one is we must use excess metal, add excess silver metal into corn nitrate acid until there is no further reaction, which is a brown gas or brown film given out. The second one is we need to remove the unreacted silver by using filtration, and our target, which is a silver nitrate, is in the filtrate, so we should correct the filtrate. The next one is we try to make the solution more concentrate by boiling to concentrate or boil to saturate. In order to prepare crystals, we should allow the solution cool down for a long time. Finally, how can we get the crystal is by using filtration again. We filter the solution and correct the crystal. Wash with small amount of cold water to remove the soluble impurity on the top, and then dry in desiccator. And let's have a look how the mark is allocate. The first one is excess silver combined with remove unreacted silver will be the first mark. Then boil the solution to concentrate will be the second mark. Allow the solution cool down for a long time, the third mark. Finally, filter, wash, and dry will be the fourth mark. But I want to emphasize here is, well, this time, do not dry your crystal in oven, because as a silver metal, don't forget, silver can be extracted by heating the ore alone. So if you put the crystal in the oven, the heat energy may be high enough to decompose your silver nitrate. That's why I suggest you use desiccator. Right, this is a long question. Part B, what is the oxidation number of silver? Well, easy, 0, and nitrogen in nitrate acid right here, of course, equals to positive 5. And why silver nitrate solution should be kept in brown bottle is because light energy can speed up the decomposition. And here is our answer. To slow down the decomposition by light. Finally, why silver is often recovered? Because silver is an expensive metal. Right, this is our question 1. For question 2, why the lead-2 bromide should be in molten state? Because it is an ionic compound. In order to carry electrolysis, you must get a closed circuit to let ions mobile for conducting electricity. Part B, what would be observed around X? So let's see. X is here, and here we can find that X is direct connect to positive side. So electrons are moving in this way. Something will try to lose electron in X, and we have lead-2 bromide, which is Pb2 plus and Br minus. So equation first. The one who can lose electron is bromide ion. Next one is what will be observed. Now, you should pay attention. Bromine is a liquid in room condition already. But don't forget, now you are heating. As a result, the bromine liquid will be vaporized. So we can observe orange-brown gas formed from X. You can keep in mind which is bromine gas. But no need to mention here because you were asked about the observable change only. And then, do you expect any color change in the copper 2 sulfate solution? So let's check. This is the copper 2 sulfate solution, but as both electrodes are made of copper, as a result, we can expect that while electron come in here, coming out here, copper will be the one who take the redox reaction. As the answer will be no. And why? Of course, because here is the first answer, first statement. Copper will lose electron in anode to form copper 2 ion, well, which is at the same way as copper 2 consumed in cathode. You can see the copper 2 will try to consume here to form a copper metal. This is cathode. But at the same time, the copper rod will give out the copper 2 ion to compensate. This is the first mark. So what about the second mark? The concentration of copper 2 ion remain unchanged. Now, everyone should alert that we are talking about the concentration, not the number. It sounds like the same, right? If the volume unchanged, then the concentration should equals to the number of mole, right? But in public exam, they only accept concentration. And here, you should pay attention to this. Next one, you are given the amount of electron and try to calculate the amount or the time needed to collect 1.7 gram of copper. First, we find the number of mole first. 1.7 gram copper equals to this amount of mole. And because 1 mole copper need 2 moles electron, and the result, we need this amount of electron. We need 6,000 something seconds. And finally, where we should perform this experiment, of course, in film cupboard. The reason behind is simple, because toxic bromine gas is given out. And this is question 2. Question 3. This is a question about writing half equation in a rechargeable battery. So we have a look. We have solid cadmium and nickel 4 oxide. Very good. You are given the formula. At the end of the reaction, you will get cadmium hydroxide and nickel 2 hydroxide. And you can find that I use 2 colors to represent the reagents. Don't forget we have the alkaline electrolyte. That is an alkaline environment. And here we start. Start from cadmium. At the end, we got cadmium hydroxide. 2 hydroxide ion is needed and balance the charge. Now, left hand side, we got 2 negative. So we got 2 electrons on right hand side. Finish. The second one, nickel 4 oxide. At the end, we got nickel 2 hydroxide. Now, give you some hints. At the first in the red half equation, you alert that hydroxide is consumed. Well, that means in order to balance the number of hydroxide, you must produce some hydroxide here, right? In the second equation. And don't forget, here shows hydrogen on the right hand side. That means something related to hydrogen should be appear in left hand side. And I'm sure you get the answer. Water is needed. And at the end, we produce 2 hydroxide ion. And don't forget, 2 electrons will be accepted here. And we finish the ionic half equations. And then part B, we combine them together. Here shows. So which one will be added as anode? Of course, N-ox. So the cation will undergo oxidation. Why? Because it lost electrons. Question 4. So you are used ammonia gas pass through hot copper 2 oxide until no further reaction and become water. And something interesting here is reddish brown powder formed on copper 2 oxide. So of course this is a sign for copper metal, right? Yes, we are using ammonia to be the reducing agent, just like hydrogen. So maybe you can copy down, just like hydrogen, CO or C. Name this product. Good, of course we can do it. And the equation involved. First, we understand copper 2 will become copper. What about ammonia? According to the equation, or hydrogen in ammonia will turn into water at the end. So in order to balance the number of hydrogen, let's see. On left hand side we got 2, so on right hand side we got 3. The coefficient is easy. With this idea, we need 3 oxygen, and it comes from copper 2 oxide. And don't forget, we got 3 copper metal form. It sounds good, right? 2 ammonia molecule can extract 3 copper metal. And don't forget the nitrogen. So where the nitrogen is gone, appear as N2. So how many mole of gaseous product are formed? This is a bit tricky because some of you may wonder, the water will appear as liquid at the end. So everything we counted should be settled down in room temperature. I think this is makes sense, right? Alright, temperature. Okay. So what we concern only is N2. So back to room temperature, the water exists as liquid, so not included in the gaseous product. And the mole ratio between the ammonia and N2 is 2 to 1. And so the mole of gaseous product is easy. Yes, it's this one. Next, after the reaction, there is some reddish brown powder formed on the surface of copper 2 oxide. So how can you obtain this reddish brown powder? That is copper metal, right? So your question here becomes, there's a mixture of CuO and copper and Cu. So how can you collect the copper metal? We just add dilute sulfuric acid. We add dilute sulfuric acid and then filter it, because copper 2 oxide is a metal oxide which is base, and it will react with acid, but for the copper metal it's too chemically inert to be reacted with acid. So the copper metal will be obtained as residue. Of course, here is some amendment here. Some of you may be not happy with that. It depends on how many marks you are given. So if you are given more marks, then more dedicated work will need to do. For example, do you need further washing with water to remove the soluble impurity on top? Right, but it depends on how many marks you are given. So we do not consider here. And finally, calculate the mass of reddish brown powder form theoretically, because there is only one mole number given here. So we assume the reaction is completed with limited ammonia gas. And here shows, first we find the mole ratio again. This time is ammonia to copper is 2 to 3. Copper is more. Because copper is more, so I sure it's times 3/2. But the story hasn't ended, because you are asked the mass and times molar mass, and we finish the job. And this is the question 4. Again, please feel free to ask me any questions in case you are not clear about the steps after watching. Okay, thank you.